Question number 9. The explosive nitroglycerin C3H5N3O9 decomposes rapidly upon ignition according to the following equation. So, here's the equation. For nitroglycerin, decomposes to form 12 carbon dioxides plus 10 waters plus 6 nitrogens plus 1 oxygen. Calculate, and the delta H of the reaction is negative 5,678 kilojoules. Calculate the standard enthalpy of formation, or delta H of F, for nitroglycerin. For CO2, and that gives the values, delta H is negative 393.5, and for H2O, delta H is negative 241.82. Well, at first glance you might think, well, they didn't tell me the delta H is for nitrogen and oxygen. Well, you don't actually need them. They're 0. All diatomic elements, like N2, O2, Cl2, whatever, those are all 0. So your basic formula for something like this is delta H of the reaction equals the sum of the delta H of the products minus the sum of the delta H of the reactants. Simple enough, right? So they told you that the for the whole reaction, it's negative 5,678 equals, now the sum of the products. So the products, we have 12 CO2, right, plus 10 waters, plus 6 nitrogen, plus 1 oxygen, minus, because it's minus the sum of the reactants, so this is the only reactant, so minus 4 nitroglycerin. Okay, so let's plug in what we know. We have negative 5,678 equals 12. Now, did they tell us for carbon dioxide? Yes, they did. It's negative 393.5. Okay, so plus 10, they told us the value for water, and it is negative 241.82. And then these two values are just 0 because they're diatomic elements. So minus for nitroglycerin. We're solving for nitroglycerin's value, which they did not tell us in the question. So what you're going to end up with is negative 5,678 plus 12 times 393.5 plus 10 times 241.4, or 0.82 rather, equals negative 4 nitroglycerin. So if you add all this up, then divide it by negative 4, then you will get the delta H for nitroglycerin, and that should be equal to negative 366, which is answer choice 4 on your test.